Okay, we're going to take a look at precipitation reactions, and we're going to use these solubility guidelines to help us with this particular idea. So the goals of this particular section are to recognize what ions are formed when an ionic compound or acid or base dissolves in water, recognize exchange reactions in which there is an exchange of anions between the cations of reactants in solution, and predict the products of precipitation reactions. And finally, write net ionic equations for reactions in aqueous solution. So we're going to start right off with writing the equation for a precipitation reaction. So is an insoluble product formed when aqueous solutions of potassium chromate and silver nitrate are mixed? If so, write a balanced reaction. So for potassium chromate, we have to figure out what the formula is. We know that a potassium ion is K+, and we can look up the formula of a chromate ion, and it's -2. And the formula, therefore, is K2CrO4, and that's potassium chromate. We can do the same thing for silver nitrate. Silver is +1. We're supposed to memorize that one. And nitrate is NO3, -1, and so the formula is AgNO3, and we're supposed to memorize the nitrate. So if we mix these two things together, we have K2CrO4. Now the question is, will this be aqueous? They say it is, but let's apply what we know about solubility rules to decide whether or not this is aqueous. Well, there are certain things that are aqueous or soluble, and those are things with group 1A ions, nitrate ion, acetate ion, and so forth and so on. And you want to become very familiar with those rules, because when it comes to quiz or exam time, you don't want to have to look them up. It takes too much time. So this has potassium in it. It is definitely soluble, so we put aqueous here. What about silver nitrate? It is also soluble because of the nitrate ion. Now, what's really handy about having these ions here is I can figure out what the product is going to be right away by comparing the ions. If there's going to be a solid that forms, it has to be an ionic compound, and it has to be a cation and an anion. So I already know that this cation and this anion are soluble, so that means it will not form a solid in water. But what about silver and chromate? Well, if I look at the solubility rules, there's no rules for silver, and there are no rules for chromate. So therefore, if it's not soluble, then it's insoluble. So that's going to be the solid or the precipitate in this reaction. So what do we do with these leftover ions? We just put them together. And then we need to balance. So let's take a look here. 2 potassiums, 1 potassium. So we put a 2 here. 1 chromate, 1 chromate. 1 silver, 2 silvers. So I put a 2 here. 2 nitrates, 2 nitrates, and we're balanced. So this is the balanced reaction. So here, if you look at the steps to help us figure out what's going on, is 1, you need to know the formulas of the reactants. And it helps to know the ions. And then what you do is you mix and match the ions to get ionic compounds. In this case, the possible ionic compounds were silver nitrate, silver chromate, potassium nitrate, and potassium chromate. So these are the 4. And we know that this one's soluble, and this one's soluble. This one's soluble because of the nitrate. This one's soluble because of the potassium. This one's soluble because of the potassium. That leaves this one as insoluble because there are no rules that govern it. And then 4, you simply write out the equation. Equation, reaction, same thing. Okay, let's take a look at another problem. Writing and balancing net ionic equations. So what is a net ionic equation? A net ionic equation is the equation that shows you what's really happening. So we want to write a balanced net ionic reaction or equation for the reaction of aqueous solutions of barium chloride and sodium sulfate. So here, with the barium chloride, we know that the ions are barium ion and chloride ion. I know that there's two chlorides, but I'm not worried about that for right now. And for sodium sulfate, I know that the ions are sodium ion and sulfate ion. Okay, I'm going to keep that in the back of my head when I'm doing this problem. So we have barium chloride plus sodium sulfate. And I want to figure out if a solid is going to form. Well, here we know that barium chloride is soluble because of the chloride. So right now I'm going to quickly make a list of the possible ionic compounds that could form. We could have barium chloride. We could have barium with sulfate. We could have sodium with chloride. Or we could have sodium with sulfate. So these are the four possible solids that could form in a precipitation reaction. Okay, we know this one is soluble because of the chloride. We know this one is soluble because of the sodium, and the chloride helps even more. We know this one is soluble because of the sodium. What about the barium sulfate? Well, if you look at the guidelines, it'll tell you that sulfates are soluble. But there are a number of exceptions to that solubility. For instance, barium ion is an exception. So that means barium plus sulfate is insoluble. So that's going to be the solid. And since I've used the barium ion and the sulfate ion, I have to use the remaining ions for my reaction. One of each because they're +1 and -1 respectively. And this will be aqueous because of the sodium. Now let's make sure it's balanced. One barium, two chlorides, one chloride, so I put a 2 here. Two sodiums, one sulfate, and it's balanced. So this is the reaction. Now, what is the net? What is the net ionic reaction? The net ionic reaction shows what is really reacting. Now, before we do the net, what I'm going to do here is this, and you don't have to do this. But sometimes it helps. So since this is just some work and it's not really an answer, notice I'm writing all the ions out. I'm not putting aqueous behind them, but we have to imagine that these ions are separate from one another floating around in solution. Now you see these ions here? Are they separate from one another floating around in solution? Nope. So we're going to write barium sulfate. So this better represents what we have when we're done with the reaction. Those ions are stuck together. Are these ions stuck together? No siree, not when it says aqueous there. Okay, if you notice on the left, we have these two chloride ions and these two sodium ions. And on the right, we have these. They're exactly the same before and after. They're not bonded to anything. There's 2 of each. What are they doing in the reaction? And the answer is they're just hanging around, watching what's going on. These are called spectator ions, and I'd like you to know that. Now, to write the net ionic reaction, which is supposed to be what is really happening, you don't need spectator ions. Now, I am going to put aqueous because that is aqueous. And there's your net ionic reaction. Let me show you another way to get to the net ionic reaction. What you do, the other way of getting to the net ionic reaction for precipitation reaction is you simply start with the precipitate. So that's what you start with. And then you ask yourself, what are the two ions that form to make this? Well, one of them is a barium ion. The other is a sulfate ion. And since the definition of an aqueous precipitation reaction is two aqueous ions, aqueous, react to form an insoluble solid, you just put aqueous behind each of these. So you start with the solid, you divvy it up into its ions, those are the reactants, and make them aqueous. And you've got the net ionic equation or net ionic reaction. Okay, looks like a blank page because I'm going to do a reveal. So here's the question. Balance the equation for the following precipitation reaction. Then write the net ionic equation. Indicate the state of each species, solid, liquid, aqueous, or gas. So here's the equation. CdCl3 plus NaOH gives you CdOH2 plus NaCl. So what we want to do here is we want to, first of all, figure out what the state is of each of these for this precipitation reaction. So with CdCl2, this is soluble because it's got chlorine. For the NaOH, it's soluble because of the sodium. Oh, I'm not supposed to put I'm not supposed to put S for soluble, I'm supposed to put aqueous. For the cadmium hydroxide, this one is a solid because if you look at the rule for hydroxides, they are not soluble unless combined with like sodium or potassium or something like that. And we know darn well that table salt is soluble. So we put in the correct state for each of these. Now what we have to do is we have to make sure this is balanced. One cadmium, two chlorines, one chlorine. So we want to put a 2 here. One sodium, two sodiums. So I'm going to put a 2 here. Two hydroxides, two hydroxides. So now it's balanced. Now for the net ionic reaction, what's the shortcut way of doing it? That's right. Start with the solid. Okay, so what are the ions that make this solid? Do we have a cadmium ion? You bet. And its charge is +2, and it's aqueous. And we have 2 hydroxide ions, and they are aqueous. So these ions are floating around in solution, and when they meet one another, they stick together, and they start forming a crystal lattice, and it becomes insoluble. So here is the answer to the balanced reaction, and here's the net ionic. Now, this was not asked, but what are the spectator ions? Well, for the spectator ions, you look at the other product. Sodium ions and chloride ions. The ions that form the other aqueous product are the spectator ions. Okay. Take a look at this next one here. Predict the products of each precipitation reaction, balance the equation, then write the net ionic equation. So here is one of them. We have nickel 2 chloride, that's aqueous, reacting with ammonium sulfide aqueous to form nickel 2 sulfide solid plus ammonium chloride aqueous. Okay. Now, let's see if it's balanced. One nickel, two chlorides, two chlorides. Oh, there's a 2 there. Two ammoniums, one sulfur, one sulfur. So it's balanced. So I believe that when I first did this, the 2 wasn't there and you had to figure that out. Not a big deal. Okay, write the net ionic equation. So remember, The shortcut is to start with the solid, decide what the ions are that make it, whoops, cross that out. And when I write the net ionic, I always like to put the cation on the left and the anion on the right, because that's the way they're going to end up in the formula. Cation first on the left and the anion on the right. So here's the net ionic reaction. Now, what are the spectators? Well, they are these ions here. So what are the ions in NH4Cl? They are NH4 plus 1 and Cl minus 1. Okay? All right. And here we have our last problem. So we are supposed to balance this. So you have to imagine that this formula, well, let's just write this formula again. So B is 3, whoops, Mn, let's start this over again. So just so that we can start fresh, we have Mn, NO3 2 aqueous plus Na3 PO4 aqueous gives you Mn3 PO4 2 solid plus NaNO3 aqueous. So let's take a look at this and let's set about balancing it. So I have 1 manganese here. I have 3 over here, so I'm going to put a 3 here. I have 3 times 2 for 6 nitrates. Here I have 1 nitrate. Here I have 3 sodiums, and here I have 6 sodiums, so I'm going to put a 2 here. And I have 2 phosphates and 2 phosphates, so it's balanced. Now, they give us the solution already that this is the product. Let's see if we would come to the same conclusion. So let's pretend that this is all we were given, and we were asked, does a insoluble precipitate form? So the idea here is it really helps if you know what the ions are. Now I know nitrate is a -1, and since there's 2 of them, the manganese has to be a +2. You know sodiums are a +1 because of where they are on the periodic table, and you should have memorized that the phosphate is a -3. So here are all the possible ions, and the possible formulas are Mn, NO3 2, Mn, 3, PO4, 2. Remember to switch and simplify. Na, NO3, and Na3, PO4. So those are the 4 possible ionic compounds that might be a solid in aqueous solution, but we can figure out whether or not they will be a solid by applying the solubility rules. This guy is soluble because it has sodium in it. This guy is soluble because it has sodium in it. This guy is soluble because it has nitrate in it. What are the rules for phosphates? Well, the rules are that they're insoluble. So what does that mean? That is going to be the precipitate. And sure enough, that's what they gave us. Now, what do we do with the leftover ions? We've used the manganese and we've used the phosphate. Well, we take these two. What would be the formula with a sodium and a nitrate? It would be 1 sodium and 1 nitrate. So we would have come to the same conclusion, and we could have balanced this just as well from this point on. Okay, so that's interesting that we could have figured that out without them telling us. But remember, we're all supposed to write the net ionic reaction. So what is the net ionic reaction? Remember, for these, this is the shortcut, and it's just much easier. Start with the solid. Then decide what ions you have. Looks like there's 3 manganese ions, and we know they have a +2 charge. And they mix with 2 phosphate ions. And they have a -3 charge. So this is your net, and this is the reaction. Okay, that's all of the precipitation slides that I have. We'll see you next time. Thank you for listening.